Hello makers. Going back some time ago I did a video on welding PLA. Some of the items I welded were difficult to weld, and there were some comments made both on the video and in the forums for R2D2 building that I picked some pretty difficult parts to weld up on the video. That mostly showed that you could weld difficult parts, but I'm going to go through the process of making a new video since the forums where I posted have now closed down and a new one's open to take its place, so we'll post a new video on it. For those of you who are not familiar with this component, this is actually part of R2D2's dome. This is actually my third attempt to make the dome. The first one, while successful, was too small due to printer calibration errors. The second one I dropped and broke, and this one is my third attempt to try and make it all work. The breaks incidentally were not where the welds were, which is another reason for wanting to replace it, because I was having trouble getting everything to line up. This is printed in two parts on my small 200 by 200 by 180 printer. I've opened up the holes, made sure that they're big enough for pins to go through. This is actually one of Mr. Baddeley's designs, and he's done a very good job of it, which is why it's so popular. I've already glued in pins into this side in preparation for this. So this, and then I've trimmed them back to the short length needed. This just slots together very easily, or it did. And we're going to clamp it prior to gluing. To make this easier to see and to weld, I'm going to clamp from the underside. Okay, always good to have all your tools handy and ready to go. This is just a cheap 3D pen. I'm using the same filament that I used for the actual print. I've just loaded that filament in this morning. Green light means it's up to temperature. For this one I'm using 200 degrees C. I actually printed at 215. You'll want something to help cool and flatten it as you weld it together. So I'm going to tack this in the middle. With the tip, push it in as far as you can into the plastic. Don't rush it, let it melt in. Then we can start the printer, the pen. Usually it takes a second or two before it starts to extrude. The further in you can get that tip, the stronger your weld's going to be, the deeper it's going to be. Just follow your seam as you drag the tip through the plastic. There's no speed race for this, so just take it easy, take it slow. When this is finished, it will be sanded, so all evidence of our welding will actually vanish. I get the right angle on this, you can see the weld. It is slightly proud of the surface, which is good. That means we can sand it back. But more importantly, it's taken, now that it's cooled down, it won't come apart. Again, we just push the filament nozzle in. That little white part on the end of the 3D pen is very hot. It is the hot part. While it's not meant to get hot, the black part that it comes out of also does warm up, so I wouldn't go sticking your finger on that either. If the tool you're using to smooth down the plastic starts to become sticky, sticking to the plastic, it just means that it's warmed up, and good time to change and use a different tool, one that hasn't warmed up. We're actually using the cool of the tool to actually, one, smooth out the print and help set the plastic. Now this is something where practice does come into its own. The more you practice, the better you'll get. You will get a little bit of stringing, particularly on the cheaper PLAs. So I've got a little bit of a lip there, and I can take that off with a file or a bit of sandpaper. I can still weld the inside. But that's come out quite well. And you can see it's very solid. Penetrate as deep as you can with your tip. Don't force it, let the heat of the tip melt in. Just a tip with these 3D pens, try not to cover the grill, otherwise that's where your heat break is on these things, and they're not fan assisted. So if you block that, it'll get hot and then it'll shut down while you're trying to weld. Most inconvenient. This method is particularly good for thin parts that you're joining. In my personal opinion, I think it's stronger than most glues, although I have heard there is a new PLA specific glue on the market. See the videos from 3D printing nerd Joel. He's done a little bit on those ones. I tend to weld still because I'm old school. The other thing is, if you do have warping on your joins from the printing process, then there's no reason why you can't do a little bit of infill while you're at it. And I've actually got on my new prints, which I've done, some joints that I'm going to have to do that on, so I might actually add a little bit showing the infill. So you might be able to see in there the crack where I haven't welded, and you can see where I have. You can see it's proud of the surface, which means we can sand it back flush to the surface. I've probably gone 2 or 3 mils below. If you have 2 large surfaces that you're planning on welding together, it might pay to help reinforce with some glue in the middle. Get your tip in. Start the printer, the pen. Now the thing is, we're actually melting the plastic on either side of our seam at the same time, and we're adding a little bit of filler in there. Mostly because when we print these we have infill, and infill in this case is not 100%, it's like 30%, because I tend to print a little bit higher on the infill than necessary. you also have end shells. As we melt at with the tip, the end shells tend to move towards the end fill, so we put in a little bit of filler and it gives us a little bit more strength there. By allowing it to come up to the surface as well, we're not distorting the material too much, and it allows us to sand it off later. Once we get close to where I start the other one. Yeah, I've done a better job before. So there's one seam, there's our other one on the inside, and I think we will tackle that as well. Remember, we're only going a couple of millimetres thick with this, so it's even more important than some of your larger ones where possible to weld both sides of your joint. It was rocking around a little bit too much for my liking, so I'm just putting another clamp on the other side to hold it up a bit, reduce some of the movement as I try and weld. .3D plastics, when left in the open, will have a tendency to gather moisture, and that's why these pens tend to extrude after you stop them, and while they're not extruding, it's actually the moisture coming out. And there tends to be a lot more moisture in the filaments we're using for the 3D pens because, one, it's exposed to the open for a lot longer than on our 3D printers, and it tends to be the offcuts from when we're 3D printing. The pens don't use much filament. You'd be lucky to use a metre in a month on a project, and you get more than that as offcut from your 3D printer. Most rolls of filament are in the 1 kilo range. That's about 330 metres. And if you're anything like me, you try and use as much as you can in the printer. My offcuts tend to be a metre or less as a result. In a lot of the welding jobs I do, that's starting to get warm, I tend to start on the inside and then do the outside. I tend to find that the insides can be more difficult, so when your parts aren't clamped properly, if you do the insides, it'll stabilise it, so it's easier to clean up any mistakes on the outside. You obviously want your outside to look better than your inside. I think that pen stopped. These 3D pens aren't very expensive. You can get them for $25 Australian, $20 US, or even less. I have seen them advertised for less. I don't know what they're like, the cheaper ones. This isn't what I would call an expensive pen. It's actually my second one. I have another one on hand for if this one fails. Might give this pen a chance to cool down. It appears to be overheating and shutting itself down while I'm welding at the end there. And I started to drift off a little bit too. So once I finish this, I can sand it back and you'd never know it was a separate piece, particularly with the layer lines in this case going the same way. Okay, I had to let me 3D pen cool down because it was starting to get too hot, and that results in it shutting down while extruding. Most inconvenient when you're trying to weld parts together. Just waiting for it to get up to temperature. And there we go. So again, we plunge the tip into the seam, deep as we can go, started extruding. See if I can follow the line a bit better than the last one. It can be difficult to do at times, particularly with the plastic being the same colour. In this case it's white. Not that it's obvious around it. Remember, the deeper we can get that tip in, the stronger our joint will be, because it'll be a thicker bit of joint. The other technique you can use is, without a 3D pen, is to use hot air. Some gas soldering irons will come with a hot air tip, so you can actually produce hot air in a focus point and actually melt the plastic and then feed filament in as a filler. Very much like you would if you were TIG welding metal. It's a method I used to use before I got a 3D pen. That worked reasonably well. So another part ready to assemble onto RT's dome. I'll tidy it up with a file and I'll add some pictures at the end. Okay, after a quick hit with the file and a bit of sanding, and you can see it's actually not too bad. That's an original print. That's where I've done a join, and this is the untouched welded. So it does come up quite well, and since this model's going to be sanded all the way through, there won't be any layer lines or anything, so it'll actually look very good.